Hi, this is Red G. York. This is a presentation on why I use statistics, which is a preview of the first chapter of the book about analyzing data statistically. This is a preview of the themes discussed in that chapter. It should help you prepare yourself for understanding the chapter. We will go over a couple of major points that'll keep you attentive to what you should be looking for. We're talking here about why use statistics. In your life, you might ask yourself um, how statistics might have been of help to you. Um, have you known of examples where someone made statements that were totally false and you were able to look it up and find out they were wrong? You might want to think about that for a moment. I hope you have some examples. I've certainly seen many of them myself. You can find things that are interesting or things on like factcheck.org, which takes politicians' statements and examines the data related to that to see how much people have erred in what they have said. Politicians tend to err a lot, of course. So what is the general issue that's addressed in statistics? Is it consistency, or is it chance, or is it adequacy? You might want to hit the pause button and think about that for a minute before answering it and coming back to hear what I have to say. Well, statistics has to do with chance. Did the data you have analyzed occur by chance? That's the big question. As we think about life, things happen by chance. You know, if you were asking questions, if you were asking people on your college campus, are you a Democrat or a Republican? First person said Democrat, second person said Republican, third person said Democrat, fourth person said Republican, fifth person said Democrat. Now you have three people who have said Democratic and two who have said Republican. Are you going to stop right then and say, oh, this means that Democrats outnumber Republicans by 3-2 on our campus? I don't think so, because chance seems to be a good explanation of that. Every other person you have asked has said the opposite party from the previous one. Very likely the next person is going to say Republican, and now you have 50-50 split between Democrats and Republicans. I want you to look at these data and see, just get an idea. Hit the pause button and look at that, get an idea of what these data show to you, and then come back. Okay, let's read the table. The client group, we have a client group and we have a comparison group. If you look at the top, client group, comparison group, you have the outcome of improvement, yes or no. You can see this to the client group that 70% of them improved, 30% of the client group did not improve. Whereas with the comparison group, that's people who did not get your service, you have a 50-50 split between those who improved and did not. So here you see the difference, 70% versus 50% is the difference that service apparently made. And you have what I call a small sample, a total of 20 people. Just want you to get that in your head, because now we're going to look at the data and decide which set of data are more likely to be statistically significant. Okay, look at this, hit the pause button, look at it, and then come back and we'll talk. Okay, I hope you're back with me now. As you can see, we have 70% of those who were in the client group improved, compared to 50% in the comparison group who improved. You may remember this is exactly the same percentage as with the previous slide. 70% versus 50%, showing this much difference between those who were in the client group and those who were in the comparison group who did not get the treatment. However, look at the sample size. We now have 200 people total in our sample. Well, if you have a much larger sample, or even a larger sample at all, you are more likely to have statistical significance. So the previous data, the one on the previous chart, here it is, where there are only 20 total people rather than 200, this is less likely to be statistically significant than this, where you have 200 people in your data. The larger your sample, the more likely your data will be statistically significant. So small samples are a bit of a problem in that regard. What was the key difference? And as we have noted a moment ago, the key difference was the sample size. So we can conclude that some things make our data more likely to achieve statistical significance. One is sample size. We've talked about that. Let me tell you one more that's not in this presentation, but I'll tell it to you anyway. It's the magnitude of the data. You noticed in our data, 50% of the people who did not get the service improved, 70% who did get the service improved. If you look at that two difference, 70% versus 50%, that shows you the magnitude of the difference. If that difference had been 70% versus 10%, that would have been a bigger magnitude. The clients in the example of 70% versus 10% would have done a lot better than those who did not get the service. I hope this is helpful to you in getting ready to read chapter 1. Hello, this is a review of chapter 1, Why Use Statistics. This is from the book on statistics that I've written. I'm Reggie York, University of North Carolina, Wilmington. So the first thing is about statistics and what does it help us to do? Does it, for example, help us to find the final proof of an assertion? Once we get the statistical significance established, then we have the final proof, or help us make decisions because we are better informed. I would say that it is the second one. B, make decisions because we are better informed. Statistics do not tend to give us final proof of anything. What are some things that contribute to the likelihood that statistical significance will be found for our data? Well, I'm going to put two things there, sample size and magnitude of data. The bigger your sample size, the more likely you will have statistical significance. Also, the greater their difference is between the two groups you're comparing, or the difference between the pre-test and post-test scores that are being compared, the more likely your data will be statistically significant. So we have sample size and we have magnitude of data to help us determine statistical significance. So this means you are more likely to find statistical significance if you have data on a larger number of people and you have data that is organized as a dichotomy. I'm sorry, back up here. This is a multiple choice question. Which of these is correct? You may want to hit the pause button, review them, and come back. Well, the answer is A. You have data on a large number of people. That should be clear from what I've already said. However, I put in B and C just to make sure you're not going to be confused about things that do and do not influence statistical significance. Whether you've measured your variable in a certain way does not influence statistical significance. It's the size of the sample and the magnitude, as we just mentioned. When you find statistical significance, you have addressed the issue of chance. Well, this is a question again. Have you addressed the issue of chance as the explanation of your data, or you can be more confident that a repeat of your study would have similar results in general, or both of the above? Excuse me. The answer is both of the above. You've dealt with chance, of course, that's what statistics is all about. But also, you can be more confident that repeating it would have similar results. That's one of the main reasons why examining statistical significance is useful. Which of these statements is or are true? Statistical significance refers to what your data can be explained by chance, whether your data can be explained by chance. 2, practical significance refers to whether the magnitude of the data are clinically noteworthy. Okay, number 1 should be very clear. We've talked about that a lot. It is chance. Number 1 is a correct statement. Number 2, we've spoken of less practical significance. Number 2 is also correct. Practical significance refers to whether the magnitude of the data are clinically noteworthy. How much of a difference was there between groups? How much of a difference was there between the pretest score, the mean pretest score, and the mean post-test score, and so forth? So the answer is both of the above are true. What mechanism specific helps us to address the level of statistical significance? So I'm giving you several different options here. Is it the value of t? Does the value of t tell you whether you have statistical significance? Or r, which indicates the correlation coefficient? Or is it p or something else? You may want to hit the pause button and think about that for a moment. The answer is p, the value of p. Now let's look at what a given p-value means. A p-value of 0.23 means what? Does it mean your clients gain 23% more than those who did not have the service? Or the likelihood of these data occurring by chance is 2.3 times in 100? Or the likelihood of these data occurring by chance is 23 times in 100? Which is true? Excuse me. The true statement is number 3. The likelihood of these data occurring by chance is 23 times in 100. If you take the value of p and multiply it times 100, you'll convert it from a fraction to a whole number, and that's what you do before you determine what the value of p means in regard to number of times in 100. Let's look at the question of what is the study hypothesis. Is it an educated guess about what the data will look like when analyzed? Or is it the difference between the pretest score and the post-test score? Or a statement of what was found in your data? Think about that for a moment. The answer is number 1, an educated guess about what the data will look like when analyzed. It's not about the difference between the scores. It's not about what you found. It's about what you expect to find. Let's look at 2 examples of study hypotheses and see which one is the better one. Look at those 2 and see what you think. Well, number 2 is the correct answer. Post-test scores will be higher than pre-test scores. You may have a little bit more information and that would be fine, but pre-test scores will be higher than post-test scores. That tells you what you need to know in order to test the hypothesis. You're looking at scores, and they come in the form of post-test scores and pre-test scores, and you expect post-test scores to be higher. The first one has 2 different flaws. Clients will get better because the treatment is effective. First flaw is it does not give you the details that number 2 gives you, and it doesn't give you any guidance on how you're going to test the hypothesis. The other flaw is it has an assertion of causation. It says because of the treatment. The testing and confirmation of an hypothesis is not a test of causation. So that's just an inappropriate statement there. What is a variable? Is it something that is constant or something that varies? Well, of course, a variable must vary. So B is the correct answer there. Do you have the variable of gender in your study? If all 23 of the persons in your study are female. If that's the case, do you have gender as a variable? The answer is no, because it did not vary. Everybody was in the same category. How about this? You failed to ask about gender on your questionnaire. Well, that may seem very obvious. and maybe even silly for me to put that on this presentation, but it has certainly happened in the experiences I've had with students over many, many years. You got to ask the question if you're going to get information on it and measure it as a variable. What's the purpose of each of these types of research? Descriptive research, explanatory research, and evaluative research. There are many different ways you could categorize research. I've decided that categorizing them by purpose is probably the most useful way to do that. Descriptive research. What is the purpose of descriptive research? Well, it is to describe people. That seems to be obvious from the word itself. What is the proportion of persons in our client caseload who have a child who is preschool age? That is a statement of description of something. What's the mean age of the people in the class we're in right now? Another descriptive statistic. It describes variables one by one. It simply describes people. Explanatory research tries to explain things by looking at the relationship between two variables. For example, do persons who exercise have less colds, the illness colds, than people who do not exercise? Well, you could compare those to see whether there is an advantage for those who exercise. You're looking at the relationship between exercise and having a cold or some other kind of illness. An example of explanatory research. You're trying to explain by looking at the relationship between variables. With descriptive research, you do not look at the relationship between variables. You only just use one variable. You report on one variable at a time. What is the mean age? And so forth. The third category is evaluative research, which has the purpose of evaluating whether a service has been effective. In some ways, it is a type of explanatory research, but because it tries to explain outcome by reference to service. But in the human services research field, evaluative research is probably the most important thing that is done. So it makes sense to make that a separate category. Which of the following are not relevant to the analysis of data? I'm going to give you a list. What is the research question? Is that relevant? 2, what is the structure of your data? Is that relevant? Number 3, what statistic can be used? Number 4, what do the application of our statistic tell us about our research question? And 5, what conclusion should we draw? Or should you say the answer is none of the above, meaning all are relevant? Hit the pause button. Think about this one for a few moments and come back. Well, I would say that all of these are relevant. So my answer to this is number 6. Well, I hope this was helpful to you in reviewing that chapter.